So you can ask me a question, just wave your hand or send me a comment in the chat. I'll respond to that. Okay, so let me begin with the first topic. In the course outline, okay, let me go to the course outline and just have a look at. I talked about projects and assignments, and in so this is the course outline. I'm just showing it. Oh, you are unable to see it, so let me share my screen first. Okay, so let me share the screen. Okay, I'm going to just get rid of this here. I'm going to share the whole desktop. Okay, applications window. So I hope you can view whatever is there on my window. Um, so in the course outline, we saw that we have got number of assignments and we have a final project. So in the assignments, the idea is to give you, as we move through the course from one topic to another, I'll give you some related assignments so that you get an hands-on experience of developing some code or doing those calculations on your own or gathering some information. The other thing is that you'll be working on projects also. So the project has got 40% grade in the marks. So it's something which I would like all of you to participate quite actively. So let me discuss about that first. Let me close this. Okay. And let me just get rid of the, okay, let me go to this kind of view. And in the view, let me, I don't want my face to be shown all the time, so I'll just turn off the video, okay, so that it's not distracting in any way. I'll put this in some corner so you can focus on the contents. Okay. So the course project is basically, I will upload these files. So there are 3 files. Yes. We'll be working. Okay, there is a question from Hi. Um, for the assignments, what Python libraries can we use for building the neural networks? We'll be using both PyTorch and TensorFlow, Keras, of course. And we'll be developing our own code. To begin with, we'll work our way through. I'll explain some of the foundational material, and I'll show you how to work with those things so that you get a deeper understanding of how these algorithms work. And we will start with the basic libraries like NumPy or MATLAB, and we'll implement those algorithms with the simple tools without going into the sophisticated libraries like TensorFlow or PyTorch. In coming lectures, of course, I'm going to go to the advanced neural networks. So we'll start using TensorFlow, and when the time arrives, I'll introduce those libraries also. Okay. All right. So let me put this somewhere here. Okay. So the projects, I'm going to upload this project description file. So this description file describes what the projects are all going to be about. So we'll begin with picking up of your project. Okay. So this gives you a glimpse of what these projects are going to be all about. So you will form basically a group of 2 to 5 students. Okay. 2 students minimum and 5 students maximum. In rare cases, I allow 1 student also, but that is under some very special circumstances. Usually, I recommend making teams, okay, and work in teams to carry out these projects. So I would strongly urge you to make teams of 2 to 5 students, 5 students at max. More than five is trouble. It's not a good idea, and less than two is also very difficult. The kind of projects that we are going to do, they require more time and more dedication and more work. So for one person, it may appear to become some daunting task. So at least 2 people should be there in the team. Okay. There'll be 2 categories of the projects. So the first category is that of implementation-based projects, and the second one is research article-based projects. So in implementation-based projects, one example could be that there are a large number of projects, large number of competitions, in fact, uh, which are being conducted at various different places. Kaggle is one place where you can go and find out that there are many competitions, machine learning and deep learning competitions are held there. And there are many well-known data sets available, freely available on Kaggle and other sites. As we move more into this course, I'll talk about these other uh, freely available data sources, so that we can play with different kinds of data, the real world data. Okay, so on Kaggle, there are many projects which are available, which people have done over past several years, and have won competitions based on that. This will give you an experience if you decide a project from the list. In the implementation-based list of projects, then this will give you a kind of exposure to the kind of work which people ranging from novice users or to average users, and to the advanced people, the people who are at the advanced level in learning, machine learning or deep learning, they are there. So there are different categories of these projects and competitions which are held, and Kaggle is one of those sites. So I would recommend all of you, in fact, to join Kaggle, and I'll also recommend some more sites in coming days so that you could see, you can get to know about the kind of work people are doing in various different areas where deep learning is being used. The other kind of projects. So one category will be, I'm calling it implementation based, is because you're not going to do something new in these projects. The main intention is that you download some data set, okay, get to know about that data set and get to know about what the problem is. And then you are going to solve that problem with the deep learning techniques that we are studying in this course. So you are going to take a data set of your own interest. Could be medical data set, could be weather satellite data set, could be traffic data set, could be, so there are large number of data sets available. So you can pick one of those data sets and can implement one or more of the deep learning techniques that we are learning in this course. Okay, all these data sets, they are some are small, some are huge. So you have a freedom to experiment with them, with those kinds of data sets. Once you get to know one data set in much more detail, you will become very confident in playing around with all other kinds of data sets, more challenging problems also. So that is the intention in the implementation-based projects, that you are going to work as a team on by picking a particular data set and working on it, developing some machine learning or deep learning model for it, testing it, going through all the stages of deep learning, and then coming up with some solution for that. As a result of that, you can also start participating in some of the competitions. You can freely participate in those competitions, and then you can earn some good money out of that if you win those competitions. Okay. The other kind of projects are research-based projects, and they are related with innovation, basically novel ideas. So they are about the kind of stuff people have been doing over past a decade or so. So I've selected some projects. There are other places to get to work on some of these research-based projects also. Sometimes the data is proprietary in these cases. Sometimes it's freely available. The authors, they publicize where the data is, and they can help you with the data also. And these articles are usually published in prominent conferences like Computer Vision and Pattern Recognition Conference, CVPR, ICML, ICCV, and then journals like Transactions of PAMI, Pattern Recognition Journal, Journal of Machine Learning and Research, International Journal of Computer Vision, IEEE Transactions on Neural Networks, xArXiv. There's so many different places where you find these are research-based articles. Now, this work is basically something which people have published as a research activity which they have carried out over several months, and they have come up with some new methods, innovative methods of solving problems. They compare those their solution methods against the existing ones, and they try to show that their methods are better than others, and that's why their work is published in these research in the form of research articles in either conferences or in journals. So in these projects, the idea is that those of you who plan to um, go deeper in the field of deep learning, and they want something innovative or something challenging, then they can go for these projects. And it's a very interesting area. The kind of things that we are doing, you can directly apply that. I mean, from the face of it, it appears that it's very difficult, but once you start working on one of those papers, the kind of papers I'm going to share with you, uh, uh, that will give you a good start to work in the research arena. You can in future you can become a great scientist working in the field of deep learning or neural networks. Okay, so since most of you all of you are graduate students and PhDs, MS or PhD students, so um, this is the kind of thing that some of you will be very much interested in doing. So I'm giving you options about both kinds of work, okay, as the project work as a part of this course. So each group can pick their project from the list, which I'm going to just show you. I'll upload it on Avenue along with this document. And so I'll give you some options how you're going to pick your project, okay? The teams will report in detail the results of their findings and comment about the understanding that they have developed about the problem domain. So again, students are encouraged to form groups of 2 to 5 members. Before the submission due date, I'm just posting the due date also. And so this will help us to carry out such work in small teams of like-minded individuals, and it will also help you to develop interpersonal skills. So it's a group activity, which means that since you're going to work in environments where people work together with each other, so there are many aspects of this kind of activity. Okay, so it's a group activity, it's a teamwork activity. You must know how to divide your work among yourselves, how to have regular meetings or regular mode of communication so that you could see the status of work on your project. And this can be something that can be a kind of lifelong experience also, because once you do this project, if you do it very nicely in a very systematic way, I'll be giving you guidance about how these projects should be carried out as we get into after the selection of the projects and assignment of the projects. I'll give you more guidelines about what is my recommended way of carrying out these projects. So you will get to know about the um, the skills and the strong areas of each other, and you can depend upon, for example, all of the group members may not be very good in programming. They may not have the ideal mathematical skills. They may not have the complete understanding of about the topic. Some could be good in communication skills, like they are good in speaking, or they are good in technical writings. Some of you could be very good in programming. So when you make teams, think about these things. Have some members in the team which are good in these areas, and then learn from each other. Okay, so that's the idea. Okay, how to pick your project? So first and foremost, you are going to form a group, and then you are going to send an email to me at my email address. Okay, and also put the subject line there so that when I do automatic filtering, it goes to the proper part of the inbox, not so it will help me to sort out things. So just put this subject line, SEP 74 project. At least this should be there in that subject line. And then also I'm going to give you the list of projects, both implementation based and research based. So you are going to rank the projects in order you would like to work on them. For example, when you say you make a list from one, two, three, four, five, so there are five projects. So the one which is at ranked at number one is the project that you would like to work the most, and the project which is ranked at number five means that you are at least interested in that as compared to other projects. Okay, so based on your preference and the popularity distribution of the projects, I'll assign the project to you. So it will be based on your preference, also on first come first basis. Okay. So you may decide to work on project on your own liking also. Now, in that case, what you need to do is to send me details of your project. Okay. So a kind of a summary of what that project is about. And also send me the links where I can go and find information about that project. Okay. So you must get my approval before that project. You can go ahead with working on that project. Okay. So apart from the list that I'm uploading, you can come up with your own idea. If you are interested in doing something using the deep learning techniques you might have heard, or you are curious of applying some particular machine deep learning technique on a problem of your own, that is also possible. Okay. Yes, there is a question. What would be the best way to get in touch with the other students? I'm going to make a discussion group on Avenue, so you can get to know about. You can ask others if they are interested in doing project with you. Then you can share information. Okay. Yes, one person in extreme circumstances when there is no alternate. Okay, I would strongly recommend to have a team of 2 to 5 students. Okay, not less than two, not more than five. That is the optimum limit. Uh, but let me know if you don't have any option. I know there could be some severe circumstances in which you cannot form group with anyone, but when you're making projects, there is sometimes a problem that if people who do projects on their own, they think that they know everything and they are the best in that area, and other people, their contribution might hinder their work. My approach is to teach them that since we live in a community of people, you must know how to work with others, learn that skill. And if somebody is not as good as you are, pass on your knowledge, teach that person, bring that person up to your knowledge level or your skill level in that area. And that way, you will not only be helping yourself in understanding that topic more in detail, because another mind, another person uh, can have zillion types of other questions, and you might not have seen those questions before, and can be very helpful in your own activity also. So my recommendation, I would say that 2 to 5 students, rare cases, I will allow one person unless there is no option, only in those circumstances. Okay. All right. What I was talking about here is that you can decide about working on a project of your own liking also, but you must get it approved by me first. Send me the details, send me more information about that project and links to the data sets that you're going to use. I must get to assess that project, whether it is at par with the other projects that I'm offering in this course or not. Okay. So once you get the approval, then you can go ahead with that project. Okay. Now, these are the things that you are going to begin with. Today is May 15th. So the first thing that we are going to do is that you're going to, okay, this is an outdated thing. I'm not going to put any marks here. So I'm just going to delete that part. So um, May 25th. May 28th, sorry, is the deadline for sending in your project options. So uh, today, after the lecture, I'm going to upload these documents, the project description that I'm talking about right now, and the list of projects also, from where you can select the projects. So I'm going to upload that. And you take your time in discussing among yourselves, discuss on the discussion board, which I'm going to open on Avenue, and then you can decide about your projects. And then this is something which I'll require from you. So I need an email from you with this thing. Just cut this part and add in your information, your student ID, your name, and put them in order. There, I've written it from 1 to 5, so 5 students at maximum, and then your project titles in rank. Okay, so you can put the project number and the title here from the lists that I'm giving, and then send it to me via email. Okay, before this date, so you have plenty of time actually. So it's about 2 weeks time. You have plenty of time to decide and go through, look into each project, and see whether you have the right kind of team to work on that project and whether you will be able to work cohesively to get good grade, good marks in that project as a result of your joint activity or not. So, so I'm giving you plenty of time to decide about these projects here. I'll add some more projects in the list that I'm uploading. I've got sufficient number of projects there. Now, this is something which is now, so after that, within a week, I'll try to assign all those projects. So in most of the circumstances, the project number one that you have selected will be allocated to you unless it has been also opted out by somebody else before you. So sending of your emails to me is important. I'll keep a record. I'll check the date and time when that email was sent by you. And also when you send that email, send a CC it to your group members also, so that I know what group we are talking about. Okay. So it's not only one single student is going to send me, a single student of the group is going to send me an email, but that student should make sure that all the other um, um, CC goes to the other members of the group also. Okay, so I will most probably you'll get the first option. If that project has been allocated to some other group, then I'll allocate the project number two and so on. Okay, so we'll see. Hopefully, out of all those fives, in rare circumstances, I've seen that we go beyond this number five, but most of the time you get first, second, or third at most. But okay, you never know. There are always exceptions. So I'll try to do those project assignments, allocations by June 4th. Um, After that, yeah, I'm coming to that. I'm just going to talk about that, Marlin. The question is about what format uh, we need to use for writing down the project report or other things. Okay, so I'll be talking about that in a moment. Just wait for it. Okay, so um, once the projects have been allocated, you are going to work on a report. The first report, okay, is a project proposal basically. and it will have 10% marks out of the project, okay? Not of the total marks, 10% of the project marks. So they will be given to that group who does this submission before June 12th. It's not based on so I will evaluating that report anyway. I'll give my comments on that. My myself and my TA will work on compiling this, and then we'll give proper comments about what needs to be modified in this proposal, and then you can work accordingly. So the idea is to get guidance from us right at the beginning before actually starting to work on that project. Okay, so this will be due by June 12th. Okay. Now, what I require in this report, I don't want a lengthy report, 1 to 3 pages, at 3 pages at most, okay? So I don't want you to spend quite a lot of time at the beginning of the project on documenting things. You can start documenting, of course, but this is just a proposal. I need to know what are the specifications of the problem that you're solving, what motivates you to solve that problem, what methodology you are going to use. Um, After going through a kind of survey of the kind of different solution techniques, what model or what methodology you are going to use to solve that problem, deep learning methodology I'm talking about, and how you're going to test and experiment with how you're going to test whether that model works fine, what are its shortcomings, how you're going to execute these experiments. And then also I would like a kind of table which shows me your project plan. I require your project to be submitted, finalized by July 30th. So before that date, you should be able to carry out all the tasks that you have in the problem specification you have laid down for you. So you must be able to plan how you're going to execute those tasks. Okay. Um, you can include pointers or reference of some existing material. No, the proposal will be the same. It's a group activity. Okay. So there is a question, will proposal from each group member be different from each other? No, there'll be one proposal submitted by a group. Okay. So you can decide who's going to do that. So one member of the group is going to do that. After I've assigned the groups, okay, and the projects, you will start working on making this proposal. Okay. And then one of your group member is going to make that submission. Again, send a copy to all the other group members also, so that everybody stays in picture, and everybody, if somebody has got some reservations about that project proposal, then he or she can communicate to me, okay, that they don't agree with some of the things, and then we can talk about that. So after submission of this proposal, there should be only one proposal per group, okay? So every person in the group is not going to send me a proposal. Okay, you must work together and decide about how you're going to execute that project, and then write it down and then send it to me, and then uh, I can comment upon what whether it is okay or whether there are some changes which are required in your proposed methodology or testing or in anything else of the project. Okay. All right. What I need in the final submission are these things. Okay. So there was a question about what format a group will use in submitting these documents. For the proposal, you can write that proposal in just as a Word document or Microsoft Word document, or you can submit it in LaTeX also, or in some other formats that I'm going to talk about even in today's lecture later. So you can use any one of the well-known word processing platform to submit that. But later on, once you have done, when we reach at the end of the semester and you are submitting your final project, then these are things which are required. So the deadline is important. Okay, so 85% of the marks are from this part. Okay, so once you have, oh, I shouldn't have deleted that. So this should stay there as 5 marks. Okay. Okay, I'll change that afterwards. Anyways, so 85% of the project marks are based on these activities. Okay, so I need the final report. I will require a recorded video presentation, and I will require your project code. Okay, so there are three important things, three important deliverables. Okay, I need a documentational proof of what you have done in this project. Okay, so I need a detailed report. Detailed report could be in the form of a Word or LaTeX report style document. So check, I'm talking about in particular the report style. This report should include these chapters or these section headings. Number one, introduction, problem statement, review and background, theory and data sets that you're using, implementation details, explanation of the source code, how you have worked out, um, or what is your methodology actually. So you can explain it with the help of diagrams here. You can have flow diagrams or other kind of diagrams people use in software industry, for example, use case or sequence diagrams. Use all kinds of diagrams that you may require there. It is as detailed as possible. Put as many, so there is no restriction on the size of this report. It should tell me all the possible details of how you have carried out that project. Okay, so you can, when you're after submission of proposal and getting my feedback about that proposal, you can start documenting some of the stuff right away. Like, and you can write down about the introduction, or you can write down about the review of the problem, the kind of data set that you're using, its detail. And then when you start implementing and writing down code, you can write down the implementation details and explanation of that source code. And then finally, the results and discussions. Okay. You will run some test cases, you'll experiment with your model and compare it with the results coming from other sources and discuss those results. And I would be really keen in looking into um, how you have analyzed your results, okay, especially when you display your results in the form of tables and um, graphs. Then I would like you to analyze those things. It's not like simply putting in the graphs, okay? The kind of things that we are learning in this course, that will help you. The understanding, the deep learning models understanding will help you to comment upon the kind of results that you're getting in your work. And then the recommendations for future work. So this is the detailed report part. Uh, I will also require a 6-page article style report. So once you have this detailed report, you can generate this report. This is like giving you a practice of um, um, making a document which can become publishable. Okay. So for that document, I would require IEEE conference style. I'll put the link in coming sessions, so you can use that link to download the standard format of an IEEE art conference style paper. So usually it is a paper of 5 pages, and it includes all your text, figures, appendices, everything, your results and graphs, etc., your analysis, conclusions. So you will follow that particular format, IEEE format, and sometimes you can add one additional page, but that is only for references. Okay, so 5 to 6 page uh, IEEE style article based on your detailed report. So there'll be some weightage for the detailed report. There'll be some weightage for this. Here, I'll be in particular looking into from a reviewer point of view, whether your article uh, fits, is publishable or not. So I'll be looking at that document from a reviewer point of view. When you submit your articles to journals, research journals, or conferences, then there are technical reviewers panel. So these people, they have long experience of evaluating the innovations and other kind of work. So I'll be using some of those things in checking how good your this part of article style report is. Okay. So this is about report. Source explanation. Okay, it's a good programming. There is a question. Source explanation is okay in the code itself. Yes, it is. But in the report, we need to know how. I mean, if you don't go to each and every line of the code, I don't want the whole code to be displayed there unless you want to. You are going to submit the code anyway, okay? So it shouldn't be a part of your detailed report. But I need to know what methodology you're using, okay? When we will discuss different deep learning methodologies, different models, they follow some pattern. Okay, so you can explain what kind of deep learning model you're using and how that model works and how you have implemented it in your source code. So you can use some graphics here like flow diagrams, or yes, you can use pseudo algorithms, pseudo code. Okay, so you can, or you can either show it diagrammatically and explain with the help of those diagrams, or you can put some algorithm or some pseudocode, and then you can explain those things. Okay. So this is the first part of your deliverables. The second part is the recorded video presentation. Okay, this is also important. I want you to make a video using, say, Zoom. So you can, the way I'm recording, you can do the same way. You can use Zoom or similar kind of packages to record your video presentation. Okay. So you are going to have a PowerPoint, or you can use Beamer in LaTeX. You can use whatever presentation platform that you like. So use that platform, and you must know how to video record it. So you can use I mean, one easy way is to use Zoom for recording. So you can do the recording, and all I need is a 15 to 25-minute duration video. Okay. And you are going to explain your project in that video. So it's a group presentation. Each member of your group must participate in that presentation. Anyone who's not participating in that presentation will not get any credit for the project. Okay, so being in that project presentation, this video presentation is a must. Okay, so if you want to get a credit for this part of the course, you must be present in that. Okay, and you must show me what is your contribution to to the project. So in the video presentation, each member of the group is going to tell me what part of the project that person has carried out, okay, and explain that part. Later on, if when we plan to have in-person or uh, sessions on Zoom, then I might ask questions to those particular individuals about their own contribution to the project. So first, I need to have that. I'll look into all these videos, and I'll prepare my questions, and I'll be asking each one of you, each one of the group members about those questions before actually assigning any marks to validate whether you have actually done work on that or not. Okay. And then the third and the most important part is the project code. Okay. I don't want any code which you have just copied from somewhere using ChatGPT or otherwise, or from some other site like Kaggle itself. You will find people solving problems and sharing their code in Kaggle. You can use those that code, but I don't want simple cutting and copying that code and posing that as if it is your own code. Okay, so that will be a severe breach of conduct if you start doing that. So when you write down your code, write it down yourself. You can seek help from all possible sources. You can seek help from ChatGPT. Modify it so that it appears, and develop your own understanding about different parts of the code. Okay, it should be your code. Okay, it should be clean, commented code. Somebody wrote that explanations should be in the code also. Yes, there should be well commented, so that if somebody else reads that, like I'll be going through that code too, so I could understand what is going on there. I'll be looking into your report, I'll be looking into your presentation, and then I'll look into your code also. So it should be easy to read and executable fully functional without any errors. Okay. Uh, you have to work on that code constantly so that when I run it, um, I shouldn't get any error at all. Okay. Um, you you can zip the code, and if you're not going to, if you're not submitting the code, it's too huge. Sometimes the data sets are huge. Okay. And they can take up a lot of space. And I'm not sure Avenue can go for that a lot of space. So in some cases, if the data sets are big enough, then I would recommend you to make a GitHub repo, and and you can upload all the stuff on GitHub or some similar platform. Um, and then you can send me the link to that, or so that I can be included in the team, or I can make a copy of that. Okay. And your code will be I'll be using, I mean, this just a so there is, the important thing is that do it yourself. Okay. There's zero tolerance policy for plagiarism, so I don't want to get into that. You see, these are the times when you get, sometimes people go for the easy way out of things. So you have plenty of time during the semester. This is just the beginning of the semester, second week of the semester. Decide about your project nicely, select a good project that you should work on, and then really work on it if you want to get something out of this course. Okay. At the end of the day, you should look back and say that I have done something remarkable in this course. Okay. As a part of a team, I have developed such and such things, and I've come to know about how to implement such and such things. Okay. I'll be looking into the technical quality of your project, how significant that work. I don't want any toy problems. I want real world problem solutions. Okay. And whether how significant it is, how novel that is. Okay. Novel means that the kind of a novel in terms of the data set you're using, or the kind of approach that you're using. Okay. So, and then your code, how well written that code is. Have you included some README files, some help files there? I'll be looking into these things. So, technical quality of the project, significance of that work, okay, and novelty of that work, and the code itself, okay. So, please make note of these things when you are making the submissions of these deliverables. These deliverables, I'll be looking each one of them. Each one has got a weightage. I'll share the rubric also, the way I'm going to evaluate each one of these things. So everyone is sure about how their group is going to be evaluated. Okay, so I'll share the rubric that I'll use for evaluating the projects. Okay. So this is just an introduction, a description of the projects. Let me move on to the lists of the projects. So let me go to the implementation type projects first. Okay. So this is this document again, along with the first document, which I was just talking about, I was reading from. I'll share this one too. So there'll be, you can expect three documents there, one about the description, the second about the implementation projects, the list of those projects, and the third about research-based projects. So this is the list of those projects. So I've got a list of about 50 projects here. Okay, plenty of projects to choose from. And I'm giving you more room. Even if you are not happy about with any one of these projects, then you can look on your own. And if you come across with a more interesting project that you feel comfortable working on, share it with me, send me its information. I'll assess it whether it is at par, it is of the same quality and level as of these projects. Then I may assign that project to you also. But first, go through these lists. Okay. I might not be able to go through each and every project. I might just um, describe some of them. For example, the first project is about music generation. Okay. So it's an interesting project in the sense that we are going to use deep learning um, things to improve uh, the music experience. So basically, we are interested in doing auto generation of music. which means that we are going to use the way the musicians work. Okay, so your deep learning model will generate music on its own. So that is the idea. There are many data sets available. One data set, I'm sharing the link with you. This is, if you go to that link, this is MIT University music library. It was used there to begin with. So you can use that as a starter. But there are other libraries, other data sets also available. You can work on those too. So main idea is that you are going to work on developing a machine learning algorithm to auto-generate music in this project. Then fake news detection. So we are all aware of that. Sometimes you come across with, especially with the social media that we have, sometimes our news feeds are flooded with fake news. So how to identify whether news article or some news is fake or real? Okay, so it's a kind of classification problem. So there are many data sets available. The data set which I'm sharing here, the fake news data set, okay, it's available on my own GitHub. You can download it from there. So it contains about 7K fake news. So it includes a title, body, and label. And then the task is to correctly classify whether a news article or news is fake or real. Okay, you are going to use some of state-of-the-art deep learning algorithm. Okay, to check the authenticity of the news. Then visual object tracking. Suppose you are in a car, okay, and you are driving slowly and you are looking at the people who are crossing the road and you are waiting for them to cross the road. Once they have crossed, you will move your car, okay? Now, this kind of thing, if we want to give um, pass on this kind of learning to our cars, self-driving cars, then this kind of activity can be achieved with the help of a camera, a video camera, and of course a controller which is going to drive the car for us. So the main idea is to track in the of field of view of the camera. There are many objects which are in motion, and we are interested in locking on one or more of these objects and track them where they go. Like when we are concentrating on different objects in a scene, we sometimes move our eyes without moving your head. So we'll move our eyes as an object moves across. Okay, so that kind of thing. And there are many things available here. You are given with a data set. You can use that data set, and there are more information about that available about this project on a website. So I'm including those links here. Um, you see, when for example, if you don't like any one of these projects, then I would like something similar, like this project information. If you want to work on your own project or the one which you would like to work, and it's not in the list here, so prepare something similar to this and send it to me. It should have links like that, but I should know what are the sources of the information, what sort of data set you are going to use. So these links should have the data sets, more information about that problem. Okay. Now this is about object detection for self-driving vehicles on adverse conditions. Sometimes we have conditions like so we've got a sudden rainfall, or we have a snowstorm, or other activities, or we have a very slippery road, or we are just passing by an accident spot. So in adverse conditions, how you are going to detect objects? Okay, so this is so you're going to again detect objects, but the conditions are different. There are different ways of doing these things. So you'll be working with videos here. um, Chatbot is something which is has become very popular. We have got so many different kinds of chatbots, Alexa, Siri. So there are many actually available here. So so they are based on very large scale language models, LLMs. And this project is about that, how to make use of the already existing LLMs, or like OpenAI, for example, and use that for your chatting application. Okay, So this is a very good project in the sense that you will come to work with some of the state-of-the-art LLM and see how it works, how for your own application you can use it. Okay. So this is an interesting, in fact, there are many different areas in which you can make these chatbots. Okay, so I've just put one project there, but it can be a project having got different applications in different areas. You know, sometimes people put chatbots on their websites to help others to get more information about the kind of things that they are doing about health sector. People will use it for their own purpose, for in a business community, on shopping mall. You can have chatbots working for to facilitate people who are doing the shopping. So there are many different application areas. So we want to get into the essence of how these chatbots are made. Then there is a lane curve detection. This is again a computer vision problem where in autonomous driving, we need to know when we are driving and we are approaching a lane curve, then how to detect that the lane is curving. Your road it has got is not going straight. There is a curve there. So how to identify that? So you can have some conditions like normal crowded night time. You don't have any lines on the road. You have shadows on the road. You have arrows or dazzling lights, or you have crossroads. So in different kind of situations, so there are many scenarios, and there is a database available for that. There is a website to support that. I will look into these and see how this problem can be solved with deep learning. Personality prediction is another thing. You want to figure out what kind of person is. Okay, so again, they have categorized the personalities of various different people in this data set. Myers-Briggs data set, it's quite famous. So again, its details can be found. Check that one out. Sign language recognition for the disabled, for those ones who don't enjoy all the good things in life, and they don't have. So for this is an application to help them, and in fact become as contributing as like ourselves. So there are different sign language standards which are being followed all over the world: American Sign Language, Australian, British Sign Language standards. So you can, so this project is about that. Okay. So you are going to look into the alphabetical images, alphabet videos, and then based on that, you are going to convert those into the sign language, the how the hand will look like when you have that alphabet or those words. Okay, so this is also very interesting, and it's a very important area. Okay, fake currency detection, um, like fake news. Okay, landmark detection when airplanes approach cities while flying in air, uh, they sometimes identify the different landmarks in the city. Okay, by aerial photography, and similarly when you are doing this on road also, you can detect some landmarks. So if you are in an unknown place, you can figure out what that place is, what that landmark is famous for. So this is also a very interesting project. Image to image translation. Now, this is becoming quite important these days. You have one type of image and you want to convert, you want to translate it to another type of image. Okay, so the for example, if you have an aerial map, okay, and you want to convert it into other formats. Okay, so you maybe want to transfer the style of the image to something other kind of style using the data. So there are different data sets which are available for this aerial photography, and you can use that to image to image translation. You use GGAN for this purpose, the conditional generative adversarial networks, and in the later part, we are going to talk about these adversarial networks, GANs also. Okay. FIFA player prediction. So over the year, different players have got different ranks. Okay, so there are different data sets which are available for the past many years, and they are available on Kaggle. You can go to Kaggle, and then there is a FIFA World Cup uh, resource available on Kaggle, and that from there you can see you can predict the ranking of a player. Okay, those who are into games, it could be a very interesting problem for them. Style transfer using neural networks. Here again, we are talking about the style. There is style associated with the like master painters or um, classical people who write very good English, like Shakespeare or others who have their own style of writing things. There are speakers, people try to follow their style, their way of speaking in public. Okay, so transferring one style to another. Okay, for example, I don't have a particular style and I speak some text. Okay, I read some text and speak. I record it, and after having that speech, I want to translate or transfer that speech to the way Obama used to deliver a speech, or somebody else who the so we will train our neural network for some people, and then based on the cycle gain, we are going to use this transfer. So you can do this. You can stylize images. You can stylize the speech. You can stylize text, etc. Dialogue generation using sequence models. Okay, now this is also important in AI. There is an age-old problem of uh, where you want to uh, check whether a machine is intelligent or not, a computer is intelligent or not. So there is an intelligence called Turing test. So it's a very old test, but still it is something which people work on and try to make their artificially intelligent computers do things according to that test. Okay, so this is something on that line, that you are going to generate dialogue using some sequence models. Okay, so there are sequence to sequence models, and you can use that to make dialogues. Now you can use it for movie dialogue generation. Okay, so this can also help you with the chatbots, virtual assistants, or real world applications in storytelling. You can use this kind of model or this kind of application. Okay, graph representation learning using graphical neural network. So there was a question, I think, in the last lecture about graph, whether we are going to use graph neural networks. So this project is about graph neural networks. So that student who was interested can have a look at this project also. This is related with graph neural network. So I told you that, okay, there are many different ways in which neural networks work or they are understood. So this is one of those. So you can use the knowledge about graphs and trees and advanced data structures. So you can use some standard database data sets also. Okay, image segmentation. Now, this is important. It also has got a wide range of applications. Image segmentation means that you are going to subdivide an image into important parts. Like if you have a medical image like X-ray or CT scan or MRI scan, and you want to figure out which part of the scan is a bone and which part is tissue, if the tissue is malignant or it is benign or it is, so you can subdivide your image into prominent segments. Okay, so how this segmentation, automatic segmentation, can be done using UNets. So there has been a paper on this, but this has been one challenge. You can use the challenge data set for this. Okay. um, Video classification using 3D CNNs. CNNs are convolutional neural networks. We'll study that in coming week or the week after that. And it's a very important deep learning neural network, and it has got a wide variety of applications. This is one of those applications, video classification. Machine translation with transformers. We know about so we know we use Chat GPT, and we've got others. So all of these have got transformers in them. So we can have machine translation with the use of these language translate. We can have a kind of language translation with the help of transformers. Anomaly detection using autoencoders. Anomalies are like when you have some data and there are some things which don't meet with the requirements of the data. No, this has got a wide range of applications, like in cybersecurity. If you want to detect the activities, okay, suspicious activities of some users of your system, okay. So from a cybersecurity point of view, it's very important. From fraud detection point of view, system monitoring, you can do all these kinds of things with the help of this project. Optical character recognition using Tesseract. Tesseract is basically an OCR engine. It's an optical recognition engine, and how you can do this handwritten character recognition with the help of this. So this project is about that. Facial expression recognition using, again, CNNs. CNNs are convolutional neural networks. Whether somebody has a sad face, smiley face, happy, um, annoyed, etc. So there are different expressions that we have. So how to do that? Image in painting using GANs. I'm going to quickly go through this because we are running. We are. Um, I've spent quite a lot of time on this, so I'm going to move quickly through the remaining projects. Okay. So stock price prediction is another using LSTMs. Okay, we will discuss this in the course also. You will work on LSTMs, and this is one of the application. Okay, here you can use Yahoo Finance data set. It's a huge data set about different kinds of currencies. This is health for healthcare problem solving. So you are going to use machine learning or deep learning for breast cancer detection. Okay. Um, Early detection of breast cancer is something which is a target of most of the um, uh, government agencies working with the healthcare. Voice recognition using deep learning. So we know about face recognition, we know about fingerprint recognition. How about speech? Not only speech, but voice recognition, recognizing a person through the voice. Okay. Image captioning, automatic captioning of images with attention mechanism. So this is also very fascinating area where you are going to uh, see the different objects in an image and see what those objects are, and then you will develop a caption based on what is happening in that image. So if you can do it for one image, then you can do it for a sequence of images, and you can narrate a video, okay, which has got no audio in it, like a dash cam video of something. So you can just give that as an input this to this kind of this kind of model, and the model will automatically generate uh, captioning or some. You can convert it to voice also. Okay, so this is also a very interesting project. Named entity recognition using BERT. This has applications in many areas, like in chemistry, in finding out in the pharmaceutical industry, where people use various different types of drugs and medicines for different diseases. And so this is called named entity recognition, how you can do it with the help of BERT. You can use OpenAI also, but BERT model is conventionally used for this purpose. Time series forecasting, this is just like stock prediction using profit. So again, this is going to use a specialized library of deep learning profit library, and then it can be used for time series forecasting. Those who want to do that are interested in going into the banking sector, maybe after graduating or helping to earn some more money on their own. This could be a good project for them. Speech synthesis using Tacotron. Speech synthesis is basically you're going to again, there are various speech data sets which are available. So you are going to generate human-like speech from text. Okay, so how to do that? Nowadays, many people are selling apps like where they have they convert the text into, for example, instead of me reading through everything here, I can automatically generate um, uh, voice or speech uh, based on the text which is written here. Okay, so document clustering using text mining, human pose estimation using deep learning, air pollution prediction using machine learning, customer segmentation using clustering, speech emotion recognition using, so from speech, how can you recognize the emotion? Okay, so sometimes when people say something, we suddenly come to know whether the person is happy or sad. So how to figure that out automatically? Recommendation systems using collaborating filtering, credit card fraud detection. This is just like fake currency. So how to do that? But this is much more advanced than that. There's a Kaggle data set available for this weather forecasting. In recent times, this has become very important with the changes that are taking place in the weather and the environment. So these kinds of applications are becoming more and more important. You see, you have different types of things. Okay, here Prophet is there, LSTM is there, NOAA is there. Okay, machine translation and sequence to sequence models. We've seen sequence to sequence models before, sec to sec before, also in one of the project. So this is another one about machine translation, image style transfer using neural networks in this case. So here you will be using state-of-the-art frameworks like TensorFlow or PyTorch. Human activity recognition using smartphones. Okay, um, medical image classification using chest X-rays. So there are about 50. So I've tried to go through all these projects, have a look at the remaining 10 projects or so. So have a list of 50 projects here. If I come up with some more interesting ideas, I'll keep updating this list. So those of you who want to carry on working on not only one project or more, they can always have a look at this. Okay. The other list is research-based projects, and again, I've got quite a few there. So like deface. So I'm just going to read through. The information is there, the links are there, so you can go through more information about these research articles. They're similar to the implementation based, but here the main idea will be to implement what these people have carried out. So sometimes you won't find any code, but sometimes you may. Okay. So I have tried to include all those papers which have got publicly available data sets with them, okay, so that you don't have any problem with the finding of the data. All you need to do is to understand what they're doing and then implement it, okay, and that implementation with and the kind of results they're producing, you should be able to duplicate their results, okay. This is kind of first exercise which in graduate education we do. We give papers to our students when we train them for doing research. We give them a paper and ask them to duplicate the work of the authors as they have carried out, because in every paper the authors usually write down in steps, in a step to step, in a stepwise manner, uh, how they have reached at the kind of graphs or tables or the conclusions that they are coming up, the kind of claims that they are making in that article. Okay, so all these papers are like that. So you are going to pick one which could be of your interest, and then you can start working on that. Some of the data sets are also used by in the implementation part. So you can see if you are unable to use that data set, you'll find some information available on Kaggle or similar kind of sites about how to use that data set. So for example, here we are using this COCO data set. It's very famous. So this is deep photo style transfer. So again, we talked about GAN. I just have quickly went through the term this GAN. Um, Generative adversarial neural networks. So cycle chain is one of those. So how we can unpair image to image translation using these networks. Um, so I've included some brief description from those papers also. This is also image to image translation using PIX to PIX dataset, fast RCNN. You only look once. YOLO, this is very famous paper of 2016 from a very well-reputed conference, IEEE Conference on Computer Vision and Pattern Recognition. If you are able to duplicate the work in any one of these papers, you will be doing the work which these guys were doing in that year. Okay, so you can see that it's not very far in the past. Okay, it's quite recent. It's within 10 years time. So you are making sure that you have the capability to duplicate somebody else's work, which they have come. So this is an important paper. But it's an easy thing. You can see when you will start implementing it, then you will see that it's a very interesting work to do. Natural style transfer. This is a review paper. Then semantic image segmentation using deep convolutional neural networks. Then you have SqueezeNet, learning to generate chairs with convolutional neural networks, an interesting paper again. Deep traffic, driving fast through dense traffic with deep reinforcement learning. Now, some people want to do that, especially when these people in the security, like in police, they are having a chase. Okay, so they would like to have controllers or some guidance system in the cars so that they could figure out because a human over response time is slow as compared to the response time of the computer. So we can actually make such kind of decisions in heavy traffic, how to drive fast and go past all the obstacles in a quickly and reach. Sometimes you need this kind of software for ambulances also because the ambulances want they need to reach at the hospital as quickly as possible. So there are many applications of this. Unsupervised representation learning with deep convolutional generative adversarial neural. Again, this is an application of GANs, DC GANs, autoencoders. We'll be talking about in the course also. So there are about 14, there are 14 papers in this list. So you can have look at other papers if you are already doing research in some other area and you want to solve your problem using deep learning. This is the time. Send me the information similar to this one. I can check that paper, check that field if it is suitable for this project, whether it is doable, it is of the same standard, then I can assign it to you. Okay, so with this, I come to the end to the introduction to the projects. Okay, if you have any questions, okay, you can ask now or we can anytime. Okay, you can send me an email about these two. Okay, so I've given you the description of how to uh, select a project out of these, and okay, yeah, there are many other models which have taken over. I'm just taking those models which are in place, okay, which have become a kind of standard. So there is a question, is the industry research still using generative neural networks? I thought diffusion models replace them. Yes, there are other models which are coming up, but as far as our understanding of deep learning is concerned, we are going to go through these models anyway, okay, how they work, to make room for it for advanced learning, going for the advanced models like diffusion models. So, of course, so the papers I've selected are relevant to the contents of the course that we have got. Okay, so in the advanced topics, I might go and discuss the other types of models which are currently being used. Okay, but all the information is not available about those. Okay. Anyways, any other question? Okay, before I stop this first part and have a break, let me move on to um, this part of the lecture, which we were looking at in the last lecture, and I'm going to just go through it quickly so that I make room for the stuff I want to discuss in the second part of this today's lecture. Okay, after the break, I'll be talking more detail about those things. So I'll just go through these things again. Um, so I in the last lecture I introduced perceptrons. So perceptron is simply um, a single neuron, and it has got its activation function. The idea of perceptron is that it is connected with some inputs. So inputs are sending some signal or information to the neuron, to the perceptron, and based on how much is the data coming in, okay? We calculate what is called the weighted sum of the input. So how much is the input is going to decide whether to get activated or not, okay? So the activation function it's going to use is like this. This is the actual activation function which was suggested at the beginning. Later on in the current models that we use, like in TensorFlow or in PyTorch or in other scikit-learn, we use perceptrons also. There, this has been modified to only a step function or a unit step activation function where theta is 0. But the generic perceptron is where theta is not 0. So it is between minus theta and theta. There is an undecisive region. And if the value of the input reaching at the perceptron becomes greater than this theta, then it's going to fire. It will become activated. Otherwise, it will give you a negative activation if it is less than minus theta. And for in between, it will stay silent. It won't say, it will be confused. Okay. So there is an algorithm to do this. In the last lecture, I talked about training data. So this is the kind of training. So this is simplest. It's a kind of toy problem that we are looking into here. So we are going to train this network starting with random weights here or zero weights on all the links. We are going to adjust the weights as this network gets more and more trained, as it repeats, goes through the data cycle over and over again, these weights will get adjusted. The adjustment mechanism to find out the new weights or to update the weights, we use the perceptron learning rule. Okay. So we will give this data like the first pattern is input x1 is 1, x2 is 1, and t is 1. Target value, expected target value is 1. So we pass that 1 on 1 here. It is only two input network, so these links are not there. So we are talking about two inputs. Each value is 1 here, and the expected value should be 1. And starting with 0, we are going to update the weight. So we'll first send these signals to this. So input going into this neuron is 0. So the result is at 0. So there is a mismatch between the expected result, which is 1, and the output, which is 0 for 1, 1 input. So because of this mismatch, we need to update the weight. And this is the way we are going to update the weights. This is perceptron learning rule. Alpha times xi times t. Alpha is the learning rate, xi is the input on ith link, and t is the target value. T is this target value. Alpha is this learning rate. For this problem, I've selected 1. And we are going to update. So this is 1. This is for this problem is 1 for the first pattern, and t is also 1. So this will be 1 times 1 times 1, 1. Old value was 0, so new weight will be 0 plus 1, which is 1. So you see the weight gets updated. The weight on this link will get updated from 0 to 1. Similarly, weight on this link will get updated from 0 to some other value according to the perceptron rule. Okay. So this I did here when I showed you this table. Um, so we start with first, so initially all the weights and the bias, they are 0. And we start with these inputs, 1, 1. The bias is always generating input equal to 1. Bias is this unit, which is always is a constant unit. So it always gives you an input of 1. The weight on the link between this bias unit and the perceptron is called bias weight. Okay. So this bias weight, I'm denoting it with B. So we are looking at these here. So we have inputs x1, x2, and this is B. So these values, so for the first set, we have 1, 1 from the training data, these 1, 1, and bias is always 1. We find out the net input going into the neuron since the initial values of weights are 0. When this input 1, 1, 1 is multiplied with 0, 0, 0, I get 0 as the total input going into, or the net input going into the neuron. And the output of the neuron is 0 according to the activation function, this activation function. So This is not the same as the desired output, the target value, which is 1. So we are going to update the weights. And for a weight update, we are using this perceptron formula. It's easy formula. It shows that it is the product of what the input here is, what is the target here is, multiply both values and multiply it with alpha, the learning rate. And that is the weight update for this particular weight. For this weight, it will be the input here and the target value multiplied with alpha. For this, it will be 1 times the target value times alpha. So for B, it will be, excuse me, the value. Okay. So we do this for the first input. We do it for the second input from the training data, the second set, the third pattern, fourth pattern. So we go through all these 4 patterns from the training data. There are only 4 patterns. And we see that the weights are changing here. If so, this constitutes what is called one epoch. If during one epoch the weights keep on changing, then you move on to the next epoch. Go through this exercise all over again. Now, this is our algorithm. This is what I've written here in the form of an algorithm or pseudocode. Okay. So you are going to execute this process all over again by picking samples one by one from the training data and then again updating the weights. You see the weights are changing. If I go to third epoch, the weights keep on changing. Third, fourth, fifth, so on to 10th epoch. In 10th epoch, I found that the weights have stopped changing. They've become fixed. Okay. So now this network gives you for every pattern, the output corresponds exactly with the target value. So whatever is the output for any pattern, it corresponds, it matches with the target value for these set of weights. Okay, so these are the weights. We call these weights, we call this perceptron a trained perceptron. With these weights, it has got trained for this kind of data, for solving this kind of problem. Okay. Now let's analyze it further. In the activation function, we have this greater than or less than kind of condition. So X is the net input. So if I look here, the net input, if it is greater than zero point 0.2, which is theta, then we get positive output. And if it is less than zero point 0.2, we get a negative output. So these two equations are, inequalities can be converted into equations. I put equality here and simplify, I get these two equations. And I can draw these two equations on an x1 and x2 plane, and they will appear in the form of two straight lines here. These are the two equations. If I plot them, they will appear like this. So they are separating this input domain, the input space, into two parts, one which is above this line, one which is below this line. And then there is an undecided region in between where theta is 0. Okay, where the output is 0. Okay, here the output is 1, here the output is -1. If I make theta 0, these two lines will merge. Okay, so a single line can be used to separate out to solve this classification problem. There are two classes, positive. So there are some data points which belong to the positive class, and there are some data points which belong to the negative class. So there are two, it's a kind of classification problem that we were solving. So we can see that this classification problem has been successfully solved with the help of perceptron rule. And that was something successful. I'll just take a few more minutes before we go for a break. And here I'm talking about we can extend this approach for solving multi-classification problems also. And one typical problem is that of font classification. If you look at these figures here, you notice that this looks like an A, this looks like B. So it's a grid of picture elements or pixels having got green or red colors. Okay. If I call green as -1 and red as +1, then this image here, this grid, can be represented by this array. Okay. This is the standard way in which an array is written in Python. So S1 is basically has got these values. You see, wherever there are greens, it is -1. There is a +1 here. This corresponds to this. Okay. So you see that you can get this whole in this form. Okay. So in fact, when we are looking at images, they are stored in this format or some format which is similar to this. Okay. This is binary format or bipolar format, but we usually use bytes for storing the actual colors and the intensity values in real images. So but just to make the problem simpler with lesser number of pixels, I'm giving this example. So you can see that there are different characters shown, letters shown. Here, I've just modified the font of each one of these characters. This is another font, a third font. Okay. And then the target values, you see, they are like the first pixel is on, the other ones are off. Second pixel is on, the other ones are off. So you can use these images or these patterns to classify alphabets. Okay. There are 7 written here. So you can design a 7 output neural network like this one. Okay, so there are 7 outputs. Instead of having one perceptron, we can have 7 perceptrons here. So M is equal to 7, and then there are N inputs. So the N corresponds to the number of samples, number of inputs here. So I'll count, there are 7 by 9 values here, 63 values. So it's a 63 long array. So I can have 63 input neurons and I can have 7 output neurons to solve this problem, to solve this alphabet character recognition problem. Okay. I can complicate this by taking real images with larger number of inputs. So the number of inputs will become equal to the size of the image in pixels. Number of outputs for English, we know there are 26 alphabets, okay? Capital letters 26 and small letters 26. We can have 26 plus 26, 52 characters recognized by a network like this, okay? Now this is a single layer network. So we need to address some other issues now. Can we extend that perceptron to solve a classification problem like this I've just shown you? Can we solve this problem with this kind of network? Okay. So when we come back, we are going to address these problems. Can we extend the perceptron rule that we have used here in solving this problem? Okay. For a single output. So can we use this perceptron algorithm where this weight update formula, the perceptron learning rule is used? Can we update it? Can we extend it for solving alphabet English character recognition problem using a single layer neural network like this or not? So we need to address this problem because we need to solve many problems like this where we usually do classification with large number of data sets and we are interested in finding out the solution to our problem. Okay, so we'll take a break here. I'll stop and I'll continue from here onwards. So let me stop the recording first. So, okay, let me first stop sharing. Okay, this, this, and I will stop the recording also.